Alright, this is the handout from today. I'm going to show you how to do an example and what I'm looking for the level of work to copy down. So there's been some conversions done for you. So 1 nanometer is equal to 10 to the negative 9 meters. And going the other way, 10 to the 9 nanometers is equal to 1 meter. The equations we're going to use is the speed of light. This is very similar to the equation we have been using, except for it's a specific speed, or speed of light, which is 3 times 10 to the 8 meters per second. We also have the energy of a photon equation. This is Planck's constant, which is given to us here, times the frequency of our wave, our light wave. Or you could also calculate it, if you don't have the frequency, you could calculate it, the speed of a wave over your wavelength times Planck's constant. All right, so we've been given wavelengths of some visible light. This is in nanometers. We need it in meters. So nanometers to meters is going to be times 10 to the negative 9 meters. Right, this is not proper scientific notation, so if I move my decimal over one spot, or 2 spots, my proper scientific notation would end up being 4 times 10 to the negative 7 meters. This is the wavelength for violet color. My frequency, we're going to use the speed of light divided by my wavelength will give me my frequency. It's this equation rearranged. My speed of light is 3 times 10 to the 8th. My wavelength is 4 times 10 to the negative 7. When I use division or multiplication with scientific notation, I do our numbers first. So 3 over 4 is going to be 0.75. And then I do our exponents separately. So when you're dividing with exponents, you have to subtract the exponent. So it's going to be times 10. 8 minus negative 7 gives me 15. And of course, this is not in proper scientific notation. We need 1 decimal over, so it's going to be 7.5 times 10 to the 14th. This is my frequency of my violet light wave. The other calculation we're going to do is the energy of this light wave or this photon, because electromagnetic waves can act like a wave or a particle. So a photon has an energy that is Planck's constant times our frequency. So Planck's constant is given to me here, 6.626 times 10 to the negative 34 times my frequency. So again, I'm going to do the 6.626 times 7.5, and this gives me 49.70. I used the same amount of sig figs that is in this number. Although, is that proper? Maybe we just need the 2. Anyway, times 10 to... When you multiply with scientific notation, you're going to add the exponent. So negative 34 plus 14 gives me negative 20. And again, we got to move our decimal place over here if we want it in proper scientific notation. So it's going to end up being 4.97 times 10 to the negative 19. And that is our answer. So I'm expecting you to put your variables into the equation and give me an answer. I do not want work that is just the answer. So please show your work as you're doing this.